Kaguya, Japan's revolutionary lunar explorer, is bringing us closer to our lonely gray neighbor than ever before. Armed with an array of high-tech tools, Kaguya is uncovering startling new evidence and unlocking age-old secrets.
That satellite has improved our understanding, our definition, just what the surface of the moon really looks like. And it ought to stir the imagination in any human being.
We'll look at how past explorations first introduced us to this alien realm and discover how Kaguya and other technologies will bring us back. This time to stay. The moon. Earth's constant companion, yet still full of mystery. Until now. This is our new window on the moon. And this is the incredible new view in high definition. Images like we've never seen them. The surface of the moon, a place of haunting beauty. Today, vivid high-definition images like these are being transmitted back to Earth from a sophisticated spacecraft called Kaguya, and with them, a whole new perspective on the moon. The Japanese Aerospace Exploration Agency blasted the Kaguya satellite into space in September 2007. It's been orbiting 60 miles above the moon's surface ever since. At 3 tons and 16 feet long, Kaguya is roughly the size of a large pickup truck and boasts 14 sophisticated tools, including special cameras, spectrometers, a magnetometer, and a plasma imager.
The Japanese Kaguya spacecraft is really providing spectacular data unlike anything we've seen before, making measurements at depth that we have never had before.
Incredible images like these may finally help us solve the mysteries of the moon and give us new insight into the origins and evolution of planet Earth. The Earth and Moon share a dramatic past. Scientists believe that 4.5 billion years ago, a rogue body as big as Mars smashed into our young planet, forever changing its destiny. They call this event the Giant Impact. The spectacular collision turns Earth into a blazing ball of molten rock, firing up our atmosphere to several thousand degrees Fahrenheit, and flings many trillions of tons of rocky debris into our orbit. This debris begins to collide and merge, and eventually, the moon is born. The power of gravity has tethered it to Earth ever since, orbiting around 236,000 miles away. The moon shines back at us each night with the same familiar face. In its glow, we may see a man in the moon, or a rabbit. But what the Kaguya satellite sees is a new set of clues about the moon's unique composition. This smooth, dark plain is called the Sea of Rays. The dark areas are craters filled with ancient lava flows and is typical of the terrain facing the Earth. The patterns we know as the face of the Moon are actually a combination of numerous craters that were long ago filled with dark lava. This is the only side of the Moon we can see from Earth. The far side of the Moon, mistakenly referred to as the dark side, has a vastly different terrain. It gets the same amount of sunlight, but has more giant craters and hardly any trace of dark lava. The question is, why are the two sides so different? Dr. Noriyuki Namiki is studying this phenomenon by using Kaguya's unique scientific instruments. He believes that the satellite's orbital path holds the key to understanding the Moon's internal structure. This is because the Moon's gravitational pull varies along the satellite's trajectory. By precisely measuring changes in the satellite's orbit, it's possible to map the gravitational fields. Kaguya uses an innovative satellite-to-sub-satellite system to relay data when it's on the far side of the Moon. These red spots highlight areas on the near side of the Moon with a stronger than usual gravitational pull, indicating high-density mass under the surface. There is no such area on the far side of the Moon. Instead, these blue spots reveal areas where the gravitational force is weaker than usual, indicating low-density mass underneath. So what caused these big structural differences in the Moon's inner core? Dr. Kiyoshi Kuramoto believes the Earth holds the key. The Moon's orbital path was once much closer to the Earth than it is today, so much so that gravity pulled it into an egg shape. As the Moon's orbit moved farther away from the Earth, it assumed its spherical shape. But there were lasting effects. Earth's gravitational force is believed to have dragged softened rock to one side, and as a result, uranium and other radioactive substances became concentrated on the near side of the Moon. These superheated materials melted deeper rock, which erupted as heavy lava, and the Moon's near side gained its signature pattern of dark and light. Earth's attraction to the heavy lava keeps the near side of the Moon forever facing inward.
地球と月のように
When a large satellite is orbiting a planet, as with the Moon and Earth, there is a strong gravitational interaction. The Moon's gravitational pull affects the Earth and vice versa. In that sense, they have been inseparable. They wouldn't have existed as they do today without having each other.
While Earth's gravity keeps the Moon in orbit, the Moon's gravity drives our ocean's tides and helps keep our climate stable and relatively mild. But our nearest neighbor is also a realm of secrets. Apollo astronauts were the first to probe this alien world. Today's technology will dare to go even further. Japan's Kaguya satellite's mission is giving scientists new insights into the Moon. It also brings us back to places we haven't seen in nearly 40 years. Like this hallowed ground, the Sea of Tranquility, where man took his first steps on the Moon in July 1969. Apollo 11's mission, to perform a manned lunar landing and return safely to Earth.
We stood a 60% chance of successfully carrying out the Apollo 11 mission. Apollo 11 was a much more challenging landing than any of the later flights. Neil did not like where the computer was taking us. He heard the 60 seconds of fuel left at about 100 feet above the ground. That I was getting a little concerned, but I didn't want to disturb the guy next to me.
Hello, Houston. This is Apollo 11. I'm reading you loud and clear. Go ahead, over.
Roger, 11. This is Houston. We had to shift stations. We weren't reading you through Goldstone. We show Pyro Bus A armed and Pyro Bus B not armed at the present time. Over.
That's affirmative, Houston. That's affirmative.
Roger.
Neil says we grabbed hands, and I remember sort of patting him on the shoulder. Then we got into the preparations for going outside.
We're awaiting confirmation of separation. That was secondary propellant on Quad Bravo. Roger, we copy.
When we got there, nothing could be more descriptive than the word desolation. When I was walking around on the surface and happened to gaze up, it caused me to realize that two people are further away from home than two people have ever been.
The astronauts have only 2.5 hours to explore this strange and daunting new world.
There's no color, just no color whatsoever. It's all just gray, shades of gray. The dust itself was just like talcum powder. What was amazing was the cohesiveness of the dust as the boot prints made an imprint. As you put your foot down and it all went out with no dust, no billowing. It doesn't do that here on Earth.
Their heavy spacesuits protect them against intense radiation and minus 280 degree Fahrenheit temperatures. But the spacesuits make some of the simplest maneuvers difficult. The Apollo 12 mission lands in the Ocean of Storms region in November 1969. This time, astronauts spend nearly 8 hours on the moon, exploring the landscape and collecting samples. In April 1970, Apollo 13 sets out to explore the Fra Mauro region of the moon. But an oxygen tank explosion cripples the spacecraft before it can land. The crew barely makes it back to Earth, a grim reminder of how dangerous lunar exploration can be. America alone seems to have conquered the moon. But a few months later, another world power crashes the party. The Soviet Union, America's space rival, manages to build, test, and launch a remote-controlled lunar rover called the Lunokhod in total secrecy. This unmanned craft explores the lunar surface in the Sea of Rains for 11 months. It transmits thousands of images of the moon's surface and completes some 500 scientific tests before dying a natural death. Its successor, Lunokhod 2, lands in the Sea of Serenity. It uses its new laser reflector to measure the distance to Earth with incredible accuracy and tries to predict volcanic activity and continental drift back home. The Lunicod rovers are a huge success, but nothing matches the manned Apollo missions when it comes to exploring the moon's secrets. In December 1972, Apollo 17 soars into the valley of Taurus Littrow. Here is that same view today from the Kaguya satellite's terrain camera. Crew member Dr. Harrison Jack Schmidt, the only geologist to visit the moon, chose the landing site.
Well, what we were trying to do is get as broad a spectrum of samples in different ages as we possibly can from the different units. And that's what the Valley of Taurus Littrow offered us the opportunity to do. Grab the railings of the ladder and sit down. Remember, we're in 1/6 gravity, so you don't weigh as much. Your mass is the same, but you don't weigh as much. So things are a lot easier in that respect, even when encumbered by that pressure suit that we had to wear. The spacesuit is the primary constraint on efficiently conducting field science. A large problem is that dust gets all over radiator surfaces, solar cells, and things like that. And you keep having to brush it off. We did occasionally try to use duct tape outside. It was impossible to keep dust off the tape with your fingers.
Schmidt and Cernan set out in the lunar rover to collect samples of rock and regolith, or moon dust. And Jack Schmidt is approaching a crater when he sees a flash of color in the sea of gray.
I was looking down at the surface, and I detected an orange hue to the debris that was covering the rim of the crater. And I had been fooled once by a reflection, an orange reflection off the lunar rover, and so I was very cautious initially about what it might be. And as I dug down, I immediately penetrated into this bright orange material.
The orange soil, as it came to be known, had scientists intrigued, but its true significance would remain a secret for decades to come. And then, it was time to leave.
Shut down right on time.
1.4 by 103.6. Roger, shut down, and we copy 101.4 by 103.6. Apollo 11, this is Houston. You are confirmed to go for orbit.
Those words were spoken on December 14, 1972. No humans have set foot on the moon since. (1972) marks the end of manned moon exploration. The Apollo program says its last goodbye to the lunar surface. The focus turns to the geological samples the astronauts collected.
We brought back, surprisingly, nearly half a ton of moon rocks, and over the 6 successful Apollo missions. We have a lot of lunar rocks and soil from 6 small areas on the moon.
One of the most unexpected finds is a pocket of orange soil amidst the moon's otherwise gray landscape. It contains the finest particles of any moon sample. Almost 40 years later, the significance of this orange soil remains a mystery. The spacecraft's powerful camera scans the entire lunar surface and finally finds what they're looking for: 40 more pockets of orange soil deposits. But what is this rare substance? Dr. Alberto Saul is trying to answer that question. He obtains orange soil samples from the Apollo 17 mission. then uses a state-of-the-art mass spectrometer to analyze its composition in incredible new detail. He determines that the soil has a strange chemical composition, but the spectrometer also finds a surprise: water.
We didn't expect to see it, given that for 40 years people tried to measure and they said there was no water. That water was not completely lost on the material that will form the proto-lunar disk that surrounded the Earth after the impact that aggregated to form the Moon.
Scientists believe that the giant impact vaporizes Earth's water, wrapping it in a warm mist. Temperatures cool, the vapor on Earth becomes water again. Because the Moon's gravity is so much weaker than Earth's, almost all of its water vapor vanishes into space. But some is preserved for billions of years, locked inside tiny fragments of volcanic rock. The mystery of the orange soil has finally been solved. Japan's Kaguya is bringing moon exploration to a whole new level, allowing scientists to study the moon's terrain like never before. Take a look at the difference. This is a picture of the moon's surface taken by an American lunar explorer in 1994. This is Kaguya's version. The previous images could only reveal craters around 1,500 feet in diameter. Kaguya can identify pits as small as 30 feet and render them in stunning 3D. The orbiter's terrain camera has two lenses, one looking forward, the other looking back. They film the same location from two slightly different angles. Combined, they bring the moon to life. Kaguya is giving us breathtaking new views of an uncharted lunarscape and allowing virtual exploration into the moon's most dramatic features. Like the crater Tycho, whose signature streaks can be seen from Earth. As this actual satellite imagery reveals, the crater is 52 miles in diameter, with cliff faces higher than those of the Grand Canyon. Studying its unique features gives us new insight into how major impacts like this one have shaped the Earth. The prominent rim gives way to a series of terraces, a common feature of the moon's larger craters. Dozens of boulders pepper the terraces. On this enormous scale, they may look like grains of sand, but some of them are as large as buildings. The terraces slope to the floor of the crater, a vast plain of rock and dust, scarred with deep cracks. In the center of the crater, a central peak soars to a height of 8,000 feet. More than 6 times higher than the Empire State Building. Kaguya's incredible cameras have captured the most detailed terrain images of the Tycho crater ever. These images allow scientists to create a theory about the crater's formation. 100 million years ago, a large celestial body strikes the moon's surface, the equivalent of detonating millions of nuclear bombs. A massive shockwave sweeps across the moon's surface at blazing speed. And blasts away 20 trillion tons of pulverized rock and dust. Debris soars as far as 1,250 miles away. This creates Tycho's unique starburst pattern. The meteor's initial impact creates a huge basin over 2.5 miles deep. The lunar surface begins to rebound from the force of the collision. Land near the rim slumps into terraces. The floor of the crater continues to rise until the bedrock pierces the surface, creating the central peak. Lunar crater analysis gives scientists a better perspective on one of Earth's hidden battle scars. Hidden under Mexico's Yucatan Peninsula is the Chicxulub crater. 112 miles across, it's twice the size of the Tycho crater, but shares the same shape and distinctive central peak. Scientists believe it's the impact site of a 6-mile-long asteroid that smashed into Earth 65 million years ago. Researchers estimate that this colossal impact dislodges trillions of tons of rock and debris. Massive clouds of tiny dust particles billow up into the atmosphere where they block out the sunlight. A significant cooling of the Earth follows and may have led to the dinosaurs' extinction. The more clues Kaguya's cameras uncover on the surface of the moon, the more we learn about our own planet and its dramatic past. Groundbreaking discoveries out here may even hold the secrets to life on Earth. The face of the moon has long fascinated us with its alien pits and pockmarks. And with almost no atmosphere or water to alter their appearance, craters retain their original form for billions of years. Now Japan's Kaguya orbiter is finding new clues in this ancient landscape. Clues that could change everything we know about the origins of life on Earth.
クレーターの数を非常に細かく
It's now possible to study the number of craters in detail, providing us with information on when small celestial bodies hit the moon, as well as their mass and quantity. Kaguya has helped us significantly boost such information.
Scientists determine the age of a crater by analyzing its state of degradation compared with others around it. They then measure its width and depth. Charting the size and age of the craters reveals an interesting pattern. A spike in moon impacts around 3.8 to 4 billion years ago. But what caused this sudden peak? Scientists once believed that comets crashing in from the outer solar system made most of the moon's craters. But that wouldn't explain the spike in activity 4 billion years ago. Dr. Fumi Yoshida thinks she's found the real culprits: asteroids. Most of these small planetary bodies orbit in a belt between Mars and Jupiter, and they've been there since the Moon was formed. Dr. Yoshida uses a highly advanced telescope to measure more than 1,000 of these asteroids. Then she compares them against the lunar craters formed 3.8 to 4 billion years ago. To her astonishment, the sizes match almost perfectly.
クレーターの大きさの分布っていうのは指紋。The size distribution of craters is like a fingerprint, and so is the size distribution of asteroids. Since the fingerprints matched, we can believe that numerous asteroids collided with the Moon some 3.8 billion to 4 billion years ago.
But why the sudden spike in activity? 4 billion years ago, Jupiter's orbit shifts slightly. This unleashes thousands of asteroids from the belt and sends them hurtling toward the Moon. And the Earth, but with much different results. Dr. Takeshi Kakegawa sets up an experiment to simulate what might have happened when asteroids hit this planet. Asteroids are largely composed of iron, so Kakegawa's team mixes that element with carbon, water, and nitrogen, very common substances on Earth 4 billion years ago. They're sealed together in a container. Next, Kakegawa simulates the massive impact of an asteroid strike on Earth. By firing the container at almost 2,000 miles an hour, the projectile unleashes a massive burst of energy on the chemicals inside. Dr. Kakegawa analyzes the chemicals and makes an amazing discovery. In addition to the original iron and nitrogen, a mysterious new substance forms. The team discovers that this material is an amino acid, one of the building blocks of life. This astounding revelation may finally explain one of the greatest mysteries facing science: the origins of life on this planet.
地球上には生命を作
The
る
Earth had all the necessary materials for the creation of life, such as carbon and nitrogen. But how were they combined? That was a question that puzzled us. But now we've come to believe that fragments from asteroids bursting on impact provided the massive energy necessary to merge the substances.
Dr. Kakegawa comes up with a scenario for the evolution of life on Earth. 4 billion years ago, oceans rich in carbon and nitrogen cover most of the planet. When the asteroid storm strikes, the impact energy melts the iron and sparks a strong chemical reaction with the carbon and nitrogen. And suddenly, amino acids are born, the key ingredient for life on Earth in all its evolving forms. The ancient Moon has no such oceans. So while the crashing asteroids dramatically shape the lunar landscape, they can never generate the spark of life. Indeed, this barren place hardly seems hospitable to human living conditions. But that's all changing. After 40 years, man is going back to the Moon. This time, to stay. "40 years ago, the Apollo astronauts first set foot on this lonely gray world.
I was strolling
on the boat one day. Get a merry monthly.
Now, NASA is preparing to go back, this time to stay. The launch is slated for the year 2020. And engineers and scientists are hard at work, trying to turn this vision of exploration into reality. But how will we get there? Where will we live? How will we get around? What will it take to stay there permanently? It's a dangerous mission, but the rewards promise to outweigh the risks.
There's a couple of reasons to go back to the moon. One is to learn how to live and work again on the surface of another world, and to be able to do it for longer than just the couple of days that we did in Apollo. And that is using the moon as a place to test out our equipment, our techniques, all our systems before we try to explore deeper in the solar system.
The area that we're basically responsible for are the habitats, so living spaces for the crews on a return to the moon. You do have to take everything that you take for granted here on Earth. You have to take your breathable atmosphere, your water system. You have to bring your power system. Unlike in a zero gravity environment where everyone is weightless, on the moon, we'll actually have a resulting floor area that is going to come into play.
But choosing the right outpost design in this wasteland is a big challenge. Any structure that goes up needs to protect its inhabitants from radiation and extreme temperatures, and must be strong enough to withstand the pelting of micrometeoroids that constantly rain down on the moon's surface. And the question of where to set up this habitat still remains.
One of the candidate sites at present is Shackleton Crater. On the south pole of the moon, you get a great deal of sunlight a majority of the time. So solar power is a very feasible solution to that. So the location makes a big difference.
But wherever they go, they'll have to find a way to work around the harmful lunar dust, which became evident during the Apollo missions.
Scientific name for this dust and soil on the moon is regolith. But what you can think of it is very, very finely divided rock and glass particles. So tiny, it's kind of like talcum powder, but really hard and sharp. Formed by hundreds of millions of years of impacts from tiny pinhead-sized micrometeorite.
Breathing it in can make astronauts sick, and the long-term effects are unknown.
Well, as soon as you take your helmet off, after you've been outside, in the lunar module, you will, there'll be dust moving around the cabin, the air circulating, and so you'll breathe it there. And it smells like gunpowder, spent gunpowder. I had a little bit of a reaction to it in what's called the turbinates. They were swollen. It was like pollen, that kind of thing. But that went away over the period we were on the moon until I hardly noticed it.
NASA scientists have made it a priority to keep the lunar dust out of the habitat and work areas.
Almost all of it has enough iron in it that it can be attracted to a magnet. And people have advocated literally lining the doors and parts of the cabin with magnets to clear dust out of the air. We also know how to use filters. And then we may well end up building spacesuits that don't come into our living space.
This time around, the suits will be easier to get into, more flexible, and better to work in for long periods of time.
everything is integrated, as opposed to the Apollo suit where you had to add all your elements onto the suit prior to going to EVA. You would have this together. Gloves would be on, you'd have your helmet, extravehicular visor, your life support system would be part of the rear hatch, and essentially all you have to do would be to open up the hatch, don the suit, and in the reduced gravity environment, the astronaut would basically grab the torso, raise himself up, and lower himself into the torso.
Scientists are also coming up with ingenious ways of harvesting vital resources from the moon itself so that astronauts can live off the land.
About 45 to 50% of the mass of the moon is actually oxygen in one form or another attached to silicon or metals. So there's an abundant amount. The trick is looking at the different minerals and coming up with a way of pulling that oxygen out. And so we have designed a plant that will operate and make about 1,000 to 2,000 kilograms of oxygen per day. This seems to be about the right size to handle a crew of 4, such that we don't have to bring any oxygen or water from the Earth once they stay there for periods of times greater than, say, 30 days. Basically, you take the bulk regolith, lunar material, you heat it up to about 900 degrees centigrade in the presence of hydrogen. The hydrogen reacts with any iron oxide and it produces a water vapor. We would then electrolyze or break that water up into oxygen and hydrogen. The oxygen we would keep and the hydrogen would be recycled back to process more regular.
Future missions will see astronauts exploring the moon's surface farther than ever before. Designs for a new generation of lunar vehicles are already underway.
We're looking at a number of different scales of machines with different capabilities. Machines that can reach up onto a lander, maybe as high as 6 meters off the soil, pick payloads up, lift them down to the surface, and then deploy them maybe as far as 1 kilometer or 2 from the lander. Those are big machines. We're also looking at some medium scale machines that can move astronauts, either with them having to wear their spacesuits in something we call an unpressurized rover, or being able to climb inside a cabin where they can just put on normal clothes and drive across the surface in a small pressurized rover. Those machines must last, crew after crew after crew. The Apollo rovers were only designed for 3 days, so that's a new challenge for us.
We bent that curve of human evolution with Apollo so that now we are really creatures of the solar system, not just of the Earth.
Life on the moon is no longer the stuff of science fiction. And thanks to the Japanese Kaguya orbiter, our closest neighbor is no longer a stranger.
Why is it important? I believe that learning more about your world is always important. And in this century, this time in human history, our world is not just the Earth. Our world is now expanding for the first time ever across the solar system and out into the universe. And the moon is that first step.